Geometry, proofs worksheet number 2. Going to do 5 of the 9 here. So if you want to check answers on the other ones that I don't do, just go ahead and check the key. All of that is posted on Google Classroom in the same location as this video, same post that is. There is also a blank worksheet there if you want that. In particular, those of you who are on quarantine could use that blank and print it out and attempt it and then watch this video and check the key. Okay, so we're going to do number 1, 3, 5, 7, and 8. And looking at number 1 here, always write the given first. So angle 2 is congruent to angle 3 is given. Mark that on the diagram. It'll help you so much if you mark things on the diagram. Angle 2 is congruent to angle 3. Okay? Now, what else do you notice? I see that angle 1 and angle 2 are vertical angles. We know that vertical angles are congruent. So angle 1 is congruent to angle 2. That's the vertical angles theorem, abbreviated VAT. Remember that you should write your justifications, your reasons in this column right here, just exactly as you see them abbreviated on the little half sheet that you get to use on all the quizzes and tests. Okay, and now we look and we have on the picture shown that angle 1 is congruent to angle 3. We actually have that. That does not mean you're done here. You still need to say it. You need to say angle 1 is congruent to angle 3. And that would be the transitive property. Transitive property of congruence, okay, or substitution. You see, when 1 is congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3. That's our transitive property. You could also see it as substitution. Looking at number 3. Number 2 is similar to number 1, so you can try that one on your own. Looking at number 3, A is parallel to B. I'll go ahead and mark that and write that down as my given. A is a parallel to B. Given. Okay. We want to prove that angle 1 is congruent to angle 3. We put this angle 2 here. You could go through the process of saying angle 1 is congruent to angle 2. That would go here, corresponding angles. Angle 2 is, that is to say, parallel lines implies corresponding angles congruent. 2 is congruent to 3. That could go on line 3 in vertical angles. And then you could say 1 is congruent to 3 by the transitive property. But you know what? We don't need to go through all that because we have an alternate exterior angles theorem. That is, parallel lines implies alternate exterior angles are congruent. So really we can jump right to the prove line and say angle 1 is congruent to angle 3. Parallel lines implies that alternate exterior angles are congruent. That's what these are. A and B are the parallel lines. We know they're parallel because the given said they are, and we marked that. And then 1 is on the other side of the transversal from 3. They are on the outside of the parallel lines. This is inside, this is outside, this is outside. Exterior, that is. Alternate exterior angles. Jump down to number 5. We know that A is parallel to B, and angle 3 is congruent to angle 4. You do not have to jam these into one line, but I was able to fit it. You could put it underneath. See, angle 3 is congruent to angle 4, and the lines are parallel. Okay, well, now take a look, and what do you notice? Well, one thing that I notice is that we have vertical angles here. You could start in a couple places on this one. I'm going to start with the vertical angles. Angle 4 is congruent to angle 5. VAT. Okay, well, now that you know that, if 3 is congruent to 4 and 4 is congruent to 5, then you could go with angle 3 is congruent to angle 5. Again, that's the transitive property of congruence. Okay, and we already had that marked, so there's nothing additional to mark because we already had 3 congruent to 4, and now 4 is congruent to 5, so now they all have that single arc mark. So now we want to bring angle 1 in, and oh, I notice angle 1 is an alternate exterior angle with angle 3, just like we saw in the a couple of proofs above here. So we can write that. Angle 1 is congruent to angle 3. Parallel lines implies alternate exterior angles are congruent. And now that I know 1's congruent to 3 and 3 is congruent to 5, I can write that 1 is congruent to 5. Angle 1 is congruent to angle 5. And that would be the transitive property once again. Okay, now I did it in this order for a reason. If you made all of the angles congruent at the first, so here's angle 1 now, and 2, there was no reason to even involve 2 because we used the alternate exterior angles theorem. The reason I did it this way is because if you made all of the angles congruent, angle 1 is congruent to angle 3, angle 4 is congruent to angle 5, someone might try to jump and say that angle 1 is congruent to 5 by the transitive property only one time. Did you notice that we used the transitive property twice, right? There's actually 4 angles involved here, and the transitive property only deals with 3, so we had to use the transitive property twice to bring in the other angles, the 4th angle, I should say. All right, moving down to number 7. N is parallel to M and A is parallel to B, so we'll show that. Double arrows would show that these two then are parallel, and we'll mark both of those as such here. A is parallel to B, and N is parallel to M, given. Looking at 1 and 5, those are not classified as anything. They are not alternate exterior. They are not same side exterior. You can't jump from one to the next intersection to another intersection, right? That's too far of a jump, okay? To say it differently, this angle right here is not a corresponding angle with angle 1. Yes, they're both in the upper left, but that's not, they're not together formed by parallel lines in a transversal. 1 and 2 are corresponding angles. Take that off there. Okay, so what I can see, and we want to show 1's congruent to 5, I can see 1's congruent to 2. Angle 1 is congruent to angle 2. As we said, those are corresponding angles. Parallel lines implies that corresponding angles are congruent. Okay, and then I'll use alternate exterior angles again. This is the 3rd time we've used that on this sheet to show that 2 and 5 are congruent. Angle 2 is congruent to angle 5. Alternate, so parallel lines implies alternate exterior angles are congruent. Okay, now I made this case in class too, but let me say this again. You must realize what parallel lines we're dealing with, right? This is going to help you a lot to understand which parallel lines are dealing with which angles. So angle 1 is congruent to angle 2 because A and B are parallel. A and B being parallel and 1 and 2 being formed by those 2 parallel lines and M the transversal is the reason why we can say line 2. However, line 3 is because M's parallel to N. You see where 2 is? It's on the exterior of M. 5 is on the exterior of N, and the transversal is B that they are on opposite sides of. Okay, so those parallel lines, the parallel lines I'm referring to here, that's A and B. The parallel lines I'm referring to here, that's M and N. And then if 1's congruent to 2 and 2 is congruent to 5, then angle 1 is congruent to angle 5. Transitive property or substitution. Now at this point you may be thinking this is a lot of the same thing, and it kind of is, and there's only so many ways we can draw parallel lines in a transversal, so we're starting to use the same things over and over again. We'll move on to something else eventually. And number 8. So, I'll do this at the end. I was going to show an alternate way to do number 7, so I'll give you a bonus. If you choose not to watch it, I'll leave it at the end so you can do that. But let's do number 8 then. And notice it wants a supplementary statement, that 1 and 3 are supplementary. Well, the only thing that I can see, I'm getting ahead of myself. Let's put the given in first. Angle 2 is congruent to angle 3, which is given. 2 and 3 are congruent. Okay, now the only other supplementary statement that I can come up with would be 1 and 2, obviously. So we'll write the measure of angle 1 plus the measure of angle 2 equals 180. And this is an abbreviation that we haven't used yet, at least not on this sheet, which is definition of supplementary angles. Use our abbreviations, please. Okay, those are supplementary angles. Obviously, they form a straight angle. 1 and 2 are supplementary, so we can make this statement, and this is the reason for that. And then we're going to put a substitution into this. If angle 2 is congruent to angle 3, then I can replace angle 2 with angle 3 here. And that's what we wanted to prove. The measure of angle 1 plus the measure of angle 3 equals 180. This has to be substitution. You don't have the option of transitive property here. This is not the transitive property. Transitive property is when you have two things congruent, and then the second thing is congruent to a third thing, and you conclude the first thing is congruent to the third thing. That's all congruence or equal measures. But this is a supplementary statement, and you're substituting into that, the 3 for the 2. Okay? All right, now, so you can end the video if you want, or you can have a little bit of a bonus here, just as an alternate way of doing this problem here. Get this stuff out of the way, and then we'll do it real quick. I just had another thought as I was doing this the first way, is what if you wanted to use supplementary instead of congruence? Could we do that? Could we go the measure of angle 1 plus the measure of angle 3 equals 180? Measure of angle 1 plus the measure of angle 3 equals 180. Well, that's true, right? Because these are alternate, same side exterior angles. 1 is on the exterior of A, 3 is on the exterior of B, and they are on the same side of M, the transversal. So parallel lines, those parallel lines being A and B, implies same side exterior angles have a sum of 180. Okay? And then we could say 3 is congruent to, supplementary with 5. We could say the measure of angle 3 plus the measure of angle 5 equals 180. Parallel lines being M and N implies same side exterior angles have a sum of 180. Okay? And then I could set those two things equal to each other. I'll try to write small here. I'll just do it on 2 lines. The measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 5, right? If this is equal to 180 and this is equal to 180, then they're equal to each other. That's transitive property or substitution. This would be transitive property of equality because it's equals here, okay? And then we could subtract the measure of angle 3's off. So one more line here. When we subtract the measure of angle 3 from each side of this equation, you'd be left with the measure of angle 1 is equal to the measure of angle 5. That's subtraction. And 2 different ways to arrive at the same thing, subtraction property of equality. And I've said before in class that this is good enough, right? When we want to say that angle 1 is congruent to angle 5, and we do say that the measures are equal, that's good enough. Okay? Thanks for watching.